All right, algebra. Well, we are looking at function notation. So, up until now, we've been using y equals equations the whole time, so doing things like making tables. And we're going to start looking at these little machines. That's the thing you see off on the right. So, with y equals equations, we'll often do things like plug a 4 in for x. And if you did that, you would end up with the result of 11. So the way the machine would look is if we have an input of 4, we get an output of 11. So if we have a 4 going into this machine, out would come 11. Now we're going to start switching to what's called function notation. It's the exact same looking equation, just instead of y, we're going to replace it with this thing called f of x. It's just a different name for the equation. So when it says find f of 5 on the right, that is really just asking for what would happen if we put 5 into the function. Well, let's go show this work. F of 5 would really mean plug 5 into this 2x plus 3 equation. So we plug the 5 in where the x was, and we're just going to simplify this down. 2 times 5 would be 10, plus 3 gets us 13. So we could write f of 5 equals 13. What that tells us is the function named f, we plugged a 5 in, and the result, what it equaled, was 13. It's a nice way of kind of organizing our inputs and our outputs. What went in was 5, what came out of this function was 13. So the nice thing about function notation is we can have different functions at the same time. So here is a new one, g of x squared minus 1, and we're going to try to find g of negative 3. So g of negative 3 says plug a negative 3 into x squared minus 1. Simplify that down, 9 minus 1 is 8. So g of negative 3, when we plug negative 3 into our g equation, out came the output of 8. Now we can start kind of working these backwards as well, where we're trying to find x. We don't know what goes into our function, but we do know the f of x, the output, is going to be 9. So if we set this up, 2x plus 3, our equation, we're trying to equal it to 9. So this is just easy algebra. Subtract your 3's and divide by 2, x equals 3. So that must mean f of 3, plugging 3 into the function f, gets us the 9 we're looking for. So let's just do round 2. G of x, you see that g of x there is equal to 3. In our equation, we can put a 3 where g of x is. So g of x, 3 equals x squared minus 1. Add the 1's over. X squared equals 4, and just like last chapter, we can square root this. We get a result, x equals 2. But remember, like last chapter, squareds need 2 answers. So x also equals negative 2. So g of 2 is one way to get equal to 3. G of negative 2 is another way of getting equal to 3. So if we have the input, we now know what gets us the 3 for the output. So this problem was backwards. We knew the output. The previous problems, we knew the input. So be very careful. People often